Hello everyone. Today we are going to go into one of the other important topic, that is problem classification. So we are discussing about problem characteristics. Now we will talk about problem classification. Okay. So why do we need to classify the problem? So you might think, so we have studied about the problem characteristics. You might think why we need to classify the problems. So can't we just use an AI algorithm for a given problem and see what happens? Can't we simply do that? But the point is simply throwing an algorithm and trying to find a solution will be a waste of time and you might get poor results. Okay? For example, if you think you are sick, if you don't go to a dentist for heart problem, what happened? So you are having a heart problem if you approach a dentist. So first, then it's very misleading and it's something absurd is there. So you must first identify the kind of problem you have, and then you have to go to the corresponding specialist. So AI also works exactly in the same way. Now we will talk about why you have to classify the problems. An AI agent can solve any problem. Okay? The very first step is to understand what kind of problem it is. Okay? So this is called as classification problem or problem classification. So different problems need different strategies. If you take a navigation problem, like finding the shortest route, like we discussed about at Bucharest to arrive. So it's a different problem completely from a medical diagnosis problem. So likewise, if you take a logical puzzle, that is not same as your scheduling problem. So when a wrong strategy is applied, we either get a wrong answer, worst answer, or never get an answer at all. So there are four key dimensions to look at. First is the nature of the solution being solved. Second, the structure of the state space. Third, the role of knowledge available to the agent. Yesterday we talked about role of knowledge. And fourth, the type of constraints involved. So why does all these four key dimensions are important? Because when you try to misclassify a problem, that leads to a wrong algorithm. So when you go for a long algorithm choice, you have poor results, waste your computation time, and ultimately you end up with no solution. So when we classify correctly, means we pick up the right technique or right choice. So this will lead to an efficient and effective solution. Okay, right? So what you have to remember here? You have to remember the categories. That is the key dimensions. Okay, right? Now we will talk about something called single state problem. So that's the first major category. So this is the simplest and most studied category in classical AI. So what exactly is a single state problem? It is a situation where the agent has complete and perfect knowledge about the world it is dealing with. Okay. The agent exactly knows what state it is in at all times, and it knows what is the result of every action. Okay. So, secondly, when you talk about the four key characteristics, the first one is it's fully observable. The environment is fully observable. This means that the agent can see everything it needs to see. Nothing is hidden. Secondly, the actions are deterministic. So when the agent does something, it knows with certainty what will happen next. Third, the agent always knows the current state. So there is no guessing. Okay. No estimation. Fourth, and there is no uncertainty whatsoever. It is. So what does the agent actually do in this kind of problem? Okay. So it searches through a known state space from a single well-defined initial state and moves towards the goal state. So the path it takes is the solution. Yesterday we were talking about path, solution state and path problem, right? Now we look at the various examples. The first one is the 8% problem. So there's a lot of discussion already happened for 8% problem and solved it using the Manhattan distance. Okay. What is an 8% problem? You have to slide the tiles. So it's 3 cross 3 grid. So that you have to attain the goal state. Yesterday we discussed the goal state was 1, 2, 3, 4, 5, 6, 7, 8 and blank. So here the full board is always visible and it is predictable. So this is a single state problem. If you take an example of route finding, so every day the Google Maps is being used. The entire road map is available. Every road, every junction, the distance, everything is available. You know, right? If every action taking a road where you will get to, you know that. So this is again a single state problem. So when you're talking about the theorem proving, where all axioms and rules are defined upfront and the agent reasons from them logically. Again, full knowledge. So what are the best algorithms for these kind of problems? You can go with breadth first search, depth first search, A star, uniform cost search. So these are your go-to tools when you are dealing with the world when everything is no. Okay. These algorithms is especially designed for environments with perfect information. When there are uncertainties involved, again the picture is completely different. We'll have to go for the different tools. Right. Now the references are again from Stuart Russell and Peter Nowell. Now with this, we'll continue this. Does does the task require interaction with your person? So this is an important aspect for classifying AI problems. And it's very practical. Ask the question like, does the task require interaction with your person? Might sound like a very simple question, but this has a lot of implications for how you design an AI system, how it reasons, how it delivers a result, all are important. Now, to begin with, not all AI tasks are the same. Every task is different. So one of the most fundamental question is in designing an AI system is whether the task requires a human in the loop or can be solved entirely by the machine. So this single characteristics changes everything about how the AI is built. A system that talks to human needs very different capabilities from the one that just process the data in background. So what does the interaction mean? Some tasks require the AI to communicate with, respond to, or collaborate with a human being during the problem solving process itself. Supposing you take the chatbots, every time you ask a question, it has to understand what you meant, okay, form a reply, and then it has to respond. So when you take a medical diagnosis assistant, tutoring system, customer servicing, all need this real-time human engagement. On the other hand, many tasks are fully automatic. So there is no need of human involvement during the execution. For example, if you take the spam filtering, the system silently classifies your emails. If you take the weather prediction, the model runs, generates a forecast. If you take image classification in a factory, the object goes past a camera, then an AI flags and detects automatically. So certain places your system is fully automatic. So if you think in the tasks you see every day where AI is involved, you might think which of the tasks are interactive, which are not interactive. Like if you take the spam detection, either an email or your WhatsApp, YouTube recommendations. So which is interactive, which is not interactive. So you might think in all these ways. So why this matters in AI design? Okay. This distinction matters enormously in the design phase. If the task requires human interaction, the AI must do several sophisticated things simultaneously. It must understand natural language because humans don't speak in structured commands. Every conversation is different. It must handle ambiguity because people are often vague or unclear. It must manage text, I mean, manage context over a conversation, remembering what was said 3 messages ago, for example. It must respond in a timely and clear manner. It must adapt to different users, different needs and communication style. If no interaction is needed, then AI can focus entirely on computation, pattern recognition, and outputting a result. The design becomes cleaner. But it also means the AI has no human to fall back if something goes wrong. It's very important, right? Next, we will talk about types of human AI interaction. Now let's get specific. So there are 4 types of interactions. So each one places different demands on the system. When we talk about the first type is the conversational interaction. So this is where the AI engages in back and forth dialogue with a human. So if you take the virtual assistants like Siri, Alexa, Google Assistant fall into these categories. So you ask something and the AI answers. It's real time, language driven, and must handle the full messiness of human communication. The second type is the collaborative interaction. Here, the AI isn't just responding, it's working along the side of a human to accomplish the task together. Suppose take an example of AI assisted surgery, where a robotic arm helps a surgeon with precision movements. If you take a co-pilot systems in aircraft, where the AI handles certain functions while the human oversees overall control. So the AI and humans are partners over here. The third one is the supervisory interaction. In this model, the human monitors and the AI can intervene or correct it if needed. For example, if you take the autonomous vehicles, they are the perfect examples. The car drives itself, but a human can grab the wheel. The AI operates independently but remains accountable to human supervisor. The fourth type is one type query. This is the simplest form where the human asks once a question, the AI answers. That's the entire interaction. A search engine is a classical example. You type a query, you get a result. So there is no conversation, no collaboration. See, you can observe these of four types form a kind of spectrum from deep ongoing collaboration to a single isolated exchange. The deeper the interaction, the more sophistication the AI needs to be. Next, we'll talk about the challenges when the interaction is required. So when a task requires human interaction, the AI faces some of the hardest problems in the field. First, understanding the intent. Humans are often vague, indirect, or even contradictory. When someone says, "Can you get me something to eat?" a human friend knows what that means based on the context. An AI has to decode this kind of utterance reliably. Second, maintaining the context. In a multi turn conversation, the AI must remember what was said earlier. If you are discussing a project and you say, change the deadline, the AI needs to know which deadline you are referring to. So, this is called the dialogue state tracking, and genuinely, it's very hard. The third one is handling emotion. Humans bring the emotional states into interactions. So, if a user is frustrated or confused, the AI must recognize that and respond appropriately, not just logically but empathetically. The fourth one is a real time response. Human expects fast replies. A 1 second delay might feel acceptable, but a 5 second delay feels broken. So, this puts a lot of pressure on latency and computational speed. Fifth is that personalization. Different users communicate differently. Some people are formal, some are casual, some give detailed instructions, others are brief. So, a well designed interactive AI adapts to the individual. So this is when an interaction is required. Now, when you what are the challenges when no interaction is required? So it might seem easier, but there are different set of challenges. When data quality becomes critical, when there is no human to provide context or clarification, the AI must rely entirely on the quality of its input data. Okay, as I say, like garbage in and garbage out. Okay, and there is no feedback loop. Suppose if the AI makes an error at the mid of the task, there's no human to catch it and say, wait, that's wrong. So the system must be robot enough to handle errors internally. Third one is interpretability. This becomes very essential, right? So if an AI flags a credit card transaction as fraudulent, someone needs to understand why. So without a human in the loop to explaining the reason, the AI must be self-evident and trustworthy. Last one is the edge cases, the unusual inputs that fall outside the training distribution have no human fallback. The system must handle them gracefully on its own or fail safely. So, what impact does this classification have on how we build the AI systems? Tasks with human interaction tend to be open ended, context sensitive, and language driven. So, what does it mean? So, meaning the problem space is not fully defined. If it is context sensitive, the correct answer changes based on the circumstance. So, when it is language driven, the preliminary medium of communication is obviously the natural language. So, this is with respect to task with human interaction. So, tasks that does not involve human interaction tend to be well defined with clear input, clear process, and clear output. And they are data driven. The AI operates purely on numerical or structured data, and it is output focused. The final result is what matters. So, this distinction directly determines the choice of AI techniques. Okay, so for interactive tasks, you likely use a natural language processing, a dialogue system, or a large language model. So, for non interactive tasks, you might be using the classical machine learning or a rule based system or a deep learning classifiers. So, choosing the wrong type of technique because you misclassify the type of problem, that's exactly the kind of expensive mistake the problem classification is designed to prevent. Now, we'll discuss some of the real world examples. So, first, we'll talk about with human interactions. So, IBM Watson for oncology is a system that advises doctors on a cancer treatment. So, it's not making the decisions alone, it's engaging the medical professionals, explaining its reasons, supporting human judgment. So, if we take the Google Duplex makes phone calls on your behalf, it has actual conversations with humans, navigating back-to-back dialogues. If you take AI tutoring system that adapts their lessons in real time based on how students respond, so it's completely interactive. If you take an example of without interaction category, Netflix recommendation engine that runs silently in the background, analyzing your viewing history and generating suggestions without ever asking you anything. If you take a fraud detection system in banking, it flags a suspicious transactions in milliseconds with no human loop involved. So autonomous quality control systems in factories uses cameras and AI to inspect the products on an assembly line. So it's fully automated. So no human needed for each inspection. So both categories are enormously valuable. Interactive AI or non-interactive AI serves with different human needs. So both are complementary to each other. Now to conclude, human interaction transforms an AI tasks from a closed, well-defined computations into an open, dynamic, socially aware process. When a human is in the loop, the AI must think not just logically but communicatively. It must understand what people mean, what they feel, and what they need. So, recognizing this need early at the problem classification stage allows designers to build an AI system with empathy, clarity, and responsiveness, not accuracy alone. A system that's perfectly accurate but can't communicate its result is not useful for human facing tasks. So, a system that's conversational but unreliable is not useful for automated tasks. So, problem classification is a discipline that helps us to ask the right questions at the very beginning so that we might get a right solution. So, the references are taken from these books. Thank you.